Okay, good evening, everyone. Thank you for joining Water Wednesday. My name is Sun Kwang-si. I'm a community affair representative at EBMUD. So let me ask you, have you visited a dam and wondered how such massive structure was built? Or question, is it safe? EBMUD diligently monitor and maintain our dams. So tonight, we will explore a piece of forgotten history of who built the nation's biggest dam in Oakland before EBMUD. And more importantly, we will have our subject matter expert to talk about the importance of dam in water management and how we keep them safe. So along the way, I invite you to ask questions. If you move your cursor to the bottom, you will see a Q&A icon. Please click it and type your questions in the window opens up. And we will answer as many questions as we can at the end of our presentation. I also like to remind everyone that we are recording this presentation and will upload it to EBMUD's YouTube channel. You will be able to view it later by searching for EBMUD Water Wednesday. Our speaker today is Elizabeth Bielek, Manager of Engineering Services, responsible for engineering oversight of dams and dam safety. We will start with Elizabeth to talk about the basics of dam.
Thank you, Sun Kwang. Next slide. And welcome everyone again to tonight's Water Wednesday. So today we're going to talk about an important part of EBMUD's water supply, an important part of water supply systems worldwide, dams. We're all familiar with major dams in the US, Hoover Dam, for example, and Orville Dam in our state, which is a major dam and part of the State Water Project, not an EBMUD dam, but interesting dam and water supply, and the tallest earth dam in the US. You may recognize San Pablo Dam pictured on the right. It's one of 5 local dams in EBMUD service area. And EBMUD actually has 24 dams, and we're going to cover that tonight. We'll provide an overview of dams and how they came to be and their role in ensuring reliable water supply for communities. Sun Kwang will tell us about the history of EBMUD dams and the role that Chinese laborers played in building Oakland dams. And we'll conclude with an overview of the steps that EBMUD takes to ensure that its dams continue to be a safe, reliable source of water and recreation for the communities we serve. Next slide. So why dams? Well, before dams, communities relied primarily on, river sources of water, and early settlements developed along rivers and creeks to supply water because that's what was needed to make life livable and sustainable. This wasn't always reliable, and particularly in arid regions like ours, we have ephemeral streams and they don't flow year-round. So reliable water supply indeed was a problem and a challenge. So the next step that people logically took was to dig wells. And some of the earliest water wells trace back to 8,000 years ago. And some of the oldest wells were created in Asia. So fun fact there about water supply. And actually in China, the percussion drilling method is believed to have been invented. And it's a method, very simple method of using, say, 3 or 4 large wooden pieces together, a rope and a heavy object, and people would be able to pull that up, drop the heavy object down, which would take out some material. They would clear that out and repeat that process and could dig deep wells. Wells were also excavated by hand with steps going down that supplied water needs for communities for millennia. Of course, this also wasn't reliable, so wells run dry. So the next logical step was dams. Now I'm completely speculating here, but I would imagine that early on people might have observed beavers damming rivers and so did the same thing to create larger pools of water. And dams also not necessarily a new invention, because the earliest known dam is the Jawa Dam in Jordan, dating back to 3000 BC. And of course, dams have been a critical part of the development of the Western United States, leading to the development of the large communities where we live. Large dams made life possible by providing a safe, reliable, consistent, multi-year water supply source that allowed for residential, commercial use, early agriculture. And what we see here is, of course, our beloved Pardee Dam, EBMUD's main water source in the McCollum watershed. It is located east of Lodi near Valley Springs. And so some beautiful photos here showing the dam and the beautiful reservoir and lake behind it that provides recreational opportunities. So next slide. So again, when we think of dams, we automatically may think of major water supply dams, Hoover Dam, EBMUD's Pardee Dam, or local dams that EBMUD operates, including Briones, San Pablo, Lafayette, Upper San Leandro, and Chabot. But EBMUD have several small dams throughout the service area that actually store treated water. These are covered and earth embankments. And this map shows all of them. And so if you take a look, you might see that there is one in your community. Now, dams are a resilient water supply and water storage solution, and you can store millions of gallons of water for drinking, recreation, and the environment. And EBMUD relies on these dams to provide water to its customers. So again, we have the two upcountry dams, Pardee, our main water supply dam, and then downstream Comanche Reservoir, which stores water for flood control and downstream uses. And again, in the East Bay, there's 5 local water supply reservoirs and 19 of these open cut reservoirs that, as we call them, that hold treated water. And the dams range in size from 15 feet to 345 feet in height, and were built from the late 1800s through the late 1960s. So wide range of dates there. And I'll note at this time, because, dams are important and they are considered high hazard structures. And we've seen certainly, unfortunately, over the history of time, many dam failures. And so our dams are regulated by the state, the California Division of Safety of Dams. And in addition, our 2 upcountry dams, Pardee and Comanche, are overseen by the Federal Energy Regulatory Commission because they generate power. And with that brief overview, I'll send it back over to Sun Kwok to tell us about the history of dams.
All right, thank you, Elizabeth. So May is Asian American Pacific Islander Heritage Month. So we want to give a shout out to the Chinese worker who built the early water system in East Bay. The first significant Chinese immigration to America is begin with the gold rush, and then it continued with subsequent large labor projects such as the building of the first transcontinental railroad. There has been little documentation of Chinese participation in the construction of the Oakland dams. In fact, hundreds of Chinese men probably drifting down from work on the railroads and in the mines in the Sierra Nevada provide the bulk of the heavy labor to the 2 major dam sites. Working for less than $1 a day, about $27 today, and risking their life in treacherous country for almost 20 years at Lake Chabot and Lake Temescal. During the time, anti-Chinese sentiment looming bigger and bigger, so the fear of Chinese immigrants coming to U.S. subsequently led to the passage of the Chinese Exclusion Act of 1882. The treatment and lives of the Chinese worker were long forgotten until 1980, when a crew repairing the Lake Chabot Dam spillway uncovered the remains of a Chinese workers' camp. The archaeological site is located on the southern bank of San Leandro Creek, 100 meters west of Lake Chabot Spillway. The site is commonly known as Yamapo or Yamabo, a Cantonese phrase meaning wild horse slope. The name is related to the hydraulic engineer Anthony Chabot using 200 wild horses stampeded the ground to build the dam. Cal State Hayward Professor George Miller and his team recovered over 60,000 artifacts from the site, including fragmented ginger jars, rice bowls, and stoneware opium pipes. We displayed some of the artifacts in our administration building's lobby, and you are welcome to check them out. So Chinese labor was indispensable at the worksite of the Chabot Dam and Temescal Dam. The dam was built by a process called puddling, which uses horses to trample the earth. Puddling makes the ground as hard and water-resistant as cement. But before the Mustang could even storm the ground, 500 Chinese workers have to bring wagon load after wagon load of dirt excavated from downstream, dump the soil at the dam, and soak it with water. Jacqueline Beggs, a retired East Bay Regional Park ranger who led the historical tour at Lake Chabot for 15 years, described in her publication that it was such horrific work, and they, the Chinese worker, had to hand dig so much, and that is why we call them the shovelmen. At Chabot Dam, 500,000 cubic yards of solid and packed earth were made by the Chinese laborer. They also clear vegetation for the project and move heavy construction equipment. Skilled Chinese masons executed the fine stonework on the dam surface. A major task at Chabot was blasting 3 separate tunnels, totaling 3,100 feet of earth and bedrock through the hillsides. At least 6 Chinese workers lost their life in cave-ins and explosions during these excavations, which city officials at that time held as a monumental achievement, but failed to mention their names. The Alameda County Historical Society declared a panel to Abing 41, Kim Yong 29, Toising 31, and Loxing 33, the 4 who they can find their names. The panel is also dedicated to the countless unnamed and unsung Chinese laborers who work on Chabot Dam. You can see the panel at the Lake Chabot when you take the historical walk. We did one last Saturday for the celebration of the East Bay Regional Park 90th anniversary. Perhaps this is not how people picture Chinese worker back then, but those Chinese workers, they really work hard and build the largest dam in America at that time. So early Chinese immigrants, they come from Pearl River Delta. They were by and large farmers and fishermen. Their village had handmade ponds for raising fish and irrigation. And as Elizabeth told you earlier, that a lot of early dam is also built in the Asian countries. So they bring some of the skill here. But also those Chinese immigrants were also merchants, carpenters, masons, artists, poets, cooks, minter, laundryman, lumberman, freighter, doctor, and others. They transferred their skill from home and from other jobs to build the Oakland dams. And note that this is one of our proud employee, Peter Lee. He is now retired, but he was a construction inspector for our wastewater division. So while a few of the Chinese come for gold, many young men, they took a 120-day long boat trip to America because they experienced extreme drought, flood, famine, political unrest, and economic chaos back home, or even worse, they were being cuckooed. For centuries, slavery was the preferred mode of labor in European colonies in the Americas. But with the stopping of the Atlantic slave trade and slavery, suddenly labor-intensive work was short-handed and without a cheap source of manpower. So in direct response to abolition of slavery, there was a robust trade involving coolies. a British colonial era term meaning a hired labor. The coolie trade run by American captains and local Chinese agents were in essence debt slavery. In Cantonese, we call the coolies so piglet, meaning that they were cheated or kidnapped to somewhere far away as slave labor. They often signed a contract and then trafficked to foreign land to do hard labors. This may explain why Chinese workers would labor for low wages and live in substandard living conditions, and because of the looming anti-Chinese sentiment, the word coolie become a derogatory code for Chinese and Asian in the United States. Most Chinese laborers, besides paying their debt, they work to send money back home to support their families there. The immigrants often identify themselves according to where they live or the region they live. And in Chinatown, benevolent organizations were formed to help these Chinese immigrants here to go back to China or coming back to the United States, and then to take care of the sick and the starving, and also to return the corpses to China for burial. Sorry. So the construction of the Earth Dam in Tasmania in 1868 was a major project. The dam rises 105 feet above the creek, which is 322 feet above sea level. The top of the dam is 300 feet long and 16 feet wide. Today, Temescal Dam is still in good condition, but no longer part of Oakland's water system. However, Lake Temescal is one of Oakland's favorite swimming area. The bigger and more functional Chabot Dam, as enduring as the 135-foot high urban dam was, it was upgraded and re-upgraded in 1892, 1967, and 1980. The dam is located within 1/4 mile of the active Hayward Fort. You can see the red line in the bottom picture. Based on seismic hazard study, in 2017, EBMUD implemented an award-winning seismic improvement to the dam. Indeed, safety is key to the effectiveness of a dam, and this is the perfect segue for Elizabeth to talk about EBMUD's dam safety program.
Thank you, Sun Kwong. So I'm going to start with a little bit about dam basics. And so many, again, people are familiar with the dams, and, their water supply dams are often constructed in river valleys and collect flow from rivers and rain and snow in the drainage area above the dams. Some dams can be offstream, meaning they're a dam in a valley area doesn't have a river, but water is pumped in. EBMUD doesn't have any such dams, but in California, there are few. So the materials typically used for the construction of dams include earth, rock, concrete, masonry, steel, timber, and miscellaneous materials such as plastic, or you might have seen blow-up rubber dams along smaller rivers, and those are actually used for water supply. Also, the community of Saratoga relies on a dam like that, and the communities of Fremont, Newark, and Union City have that type of dam as one part of their water supply portfolio. At any rate, EBMUD has one concrete dam, Pardee Dam, which again is our main water supply, and it's pictured here on the lower right. It is actually a concrete gravity dam, meaning it's supporting the water solely with its weight. It does have some arching shape, but it isn't an arch dam. If you're familiar with Hoover Dam, which we've mentioned a few times, that is a concrete arch dam, which has a larger arch and that's anchoring onto the rock slopes and relying on that force to hold back the large weight and volume of water behind it. The remainder of East Bay MUD's dams are earth embankments, and we see San Pablo Dam there on the right. And they rely on a large amount of compacted soil to hold back the water. Now, soil, of course, will always seep, and that's an issue with dams. And so modern dams are zoned embankment dams. And here's a figure that shows San Pablo Dam. And we'll see in the center, there's a clay or core material that's more compacted, and it's less permeable. So we rely on that to control some of the seepage. In addition, dams have a formal drainage system that collects the seepage in a very methodical, organized way and channels it safely through and under the dam so that we don't get erosion. And I see a question in the chat about seismic upgrades, and East Bay MUD has completed seismic study of all of its dams and several upgrades. And so in addition to Chabot, this is San Pablo, and several points in history we had added an upstream buttress, which is shown in the yellow there in the upstream portion on the right. And then in 2009, we had added an additional buttress and completed cement deep soil mixing. So that's a technology where a large drill rig drills deep through the dam and into the foundation and bedrock materials and injects cements and creates a really strong material to like hold the dam and add stability for both sliding. And in this case, when we were looking at seismic action, Sun Kwong told us about Chabot Dam and the method used to compact the materials with horses. That was actually very good because you had a good compactive action. San Pablo was built in another way in the 20s with the new technology that was used in mining called hydraulic fill that washed materials from the hillside and it flowed into the site. They did a good job with that because they channeled fine-grained materials to make the core, but the rest was subject to settlement on shaking. And so that was the reason for the upgrade. So many things pointed out there, but the point is that, you know, modern dams do have a zone system, and this is what's going on inside the dam. Another key safety feature is, of course, the spillway. And dams have a spillway, a set lower area where flow can come out in a controlled way, usually concrete lined so that you don't have erosion, so that if the water gets too high, instead of washing over the embankment and causing a problem, it'll wash down the spillway. Sort of like in your bathtub, you have that top drain that will drain water out if you have too much water so that it drains out there instead of overflowing your bathtub and going into your bathroom and home. So it's the same idea. In addition, we want to be able to release the water and use it and release it in case of an emergency. So deep within the embankment, we have pipes as shown here on the lower left. That's the upstream side and the water side, and with large valves that can open and close and let water go out through the dam. And often there's an outlet tower that's shown here that also has all of the gate controls for the reservoir. So that's a little bit about, you know, the basics of a dam. And of course, you know, as you can see, there's a lot we can see and a lot we can't readily see. And it's important that all of these features function properly to ensure safety of the dam. And now I mentioned earlier that dams are high hazard structures, and certainly historically there have unfortunately been several dam failures. And a well-known one was in 1928, the failure of the St. Francis Dam that failed catastrophically the first time it was filled. And this was due to unsuitability of the foundation materials and geology. And so sadly, the resulting flood killed 400 people, and it led to the formation of the California Dam Safety Program. And so I did mention that East Bay MUD is regulated by the California Division of Safety of Dams, and they oversee dams of the safe to make sure the public is safe. So with that, next slide. So East Bay MUD does have a comprehensive dam safety program. It includes regular monitoring, regulatory oversight, regular reevaluation as the state of the practice and evolves and we learn more about seismicity and flood. We reevaluate our dams, and of course, emergency planning and exercises. And now I'll just get to the punchline. All dams are considered safe for continued operation, and this is based on our own ongoing monitoring efforts and also as approved by our regulators who oversee the operations of our dams. Next slide. So I'm going to go into a little bit more detail on exactly what we're doing. And so surveillance and monitoring is important, and the goal is to prevent dam failure by detecting conditions that may lead to a problem, but in enough time so corrective action can be taken. And so the typical activities are routine visual monitoring, instrumentation monitoring, and periodic special inspections. And I see there was a question about what technologies we use, so I'll talk about that a little bit. So next slide. First, about the visual inspections, what are we looking for? Maybe simply stated, we're looking for water in the wrong place or things not quite right in displacements. And so I mentioned that seepage through earth embankments and a deliberate underdrain system to collect that drainage. We look at the discharge from that, and it should be clear, because if you have muddy or turbid discharge, that could be evidence of some insidious internal erosion occurring, and that could lead to a catastrophic failure. And that was the failure, for example, in Grand Teton Dam. We look for wet areas, which wet areas in and of themselves may not be a problem. They occur from time to time. A lot of times it could just be rainfall ponding, but here's an example of one that we observed for a while or one of the Comanche Saddle dams. We're looking for water flowing or bypassing a conduit, settlements or bulges. There's some pictures there in the schematic, and then, photo there that shows sloughing. And on the water side, things like whirlpools or strange movement in water. And, we have trained engineers and materials testing technicians and rangers and operators that every month take a look at the dams. And they're actually often out to the site even more and are trained to look for some kind of anomaly. But they do a detailed walk down. Dams are big. They walk in a methodical way to make sure they see everything. They look at various angles to look at, what displacements that might be happening. During, a lot of the year, the water's up, so they can't see the embankment on the water side, but they look for signs of concern. And then, of course, do a more detailed inspection when water is down. We have specific forms that are used that are dam specific that note things like, for example, a wet area for people to observe. And so we monitor these closely. So on the next slide, we show, okay, what about what we can't see? What else is going on inside? And so we look for water levels in the embankment, and we do that with a piezometer, which is shown here. It's like a narrow well that has an opening, and we insert a probe and we look at how high is the water there. There's also automatic ways with a vibrating wire piezometer that detects pressure differences, and that gives us a reading so we can see if water levels are increasing in the dam. We also look for movement on the surface of the dam or within the dam. So similar to piezometers, we have inclinometers. So it's the same kind of narrow well, and we have a probe that we insert that goes down, and it'll measure very subtle movements, and so we can see if there's any displacement, particularly at depth, going on. And so these are read regularly. We've also over time installed more automated instrumentation. So here at the bottom left, we see a survey total station, an electronic survey device that we have out at San Pablo. Actually, it's in an enclosure, but it routinely shoots targets on the dam. And so this is a real-time indication for us if there's any displacement going on in the dam. And we have either this or manual surveys at our dams, and we look at this data regularly, and trained engineers respond in case we see any differences, if we see any erosion, or that things are addressed right away. And we, of course, want to monitor water flows through the dam. So what we see here is inside this under drain. You know, we saw a schematic before, so we see what flows are going on there and how they look, how much water is maybe going over the spillway when it's a wet year, and the water volume in the reservoir. So next slide. So we're also always doing, you know, studies and completing improvements. And so as our understanding of earthquakes and floods has evolved, we've continued to incorporate this new information, not only in new designs, but in taking another look at all of our past dams and facilities to see, are they still adequate? And, you know, because of this, we're, you know, have an ongoing program of reevaluation. And so, you know, again, Sun Kwong told us about the construction of Shimbo, well compacted. And then, you know, we had concerns at San Pablo, and, you know, found a solution for that, and systematically have done upgrades to ensure that our dams are always safe. You know, another typical thing is concrete. The knowledge of reinforced concrete has evolved over the years and how to make it more seismically resistant. So we've done ongoing studies and have completed, or right now are completing, an upgrade of Briones Tower. We've completed an upgrade of the Upper San Leandro Outlet Tower, and are currently designing an upgrade for the Lafayette Tower. At any rate, so what exactly are we doing? So the safety of each dam is reevaluated with advances in geotechnical, structural, earthquake engineering, or flood science, and recommendations are implemented. We've completed seismic evaluations of all of our dams, as I mentioned, and so we have completed those upgrades. Again, San Pablo Dam, Chabot Dam, Upper San Leandro Tower, Briones Tower, and now Lafayette Tower is under design. We've performed detailed evaluations of all of our spillways. After the Orville spillway incident in 2017, we proactively started looking at our spillways. We've now studied them all, and we see people here doing a detailed walk down of the spillway and looking at areas that might have cracking, or, you know, concrete with that, you know, sounds like it might have voids, and we've done repairs, and we do that regularly actually before any spilling, and do maintenance to do crack repair and replace any areas of where we have concerns with concrete. We've also done more detailed like ground penetrating radar surveys to assess voids, and also have taken concrete samples to confirm that, and have completed repairs. We're now looking at seismic details of walls along the spillway chutes, any bridges and other appurtenances that are part of our spillways. In addition, you know, I mentioned the under drains, and, you know, it's important. Water can be insidious and do a lot of damage if it goes in the wrong place. And, you know, that was believed to be one of the contributing factors to the concerns at Orville Dam, that there was clogging and non-performance of the under drain system that caused an uplift. So we've done video surveys of our spillway subdrains in places where we couldn't access them. We've done smoke testing, as is often done in sewer systems, to, you know, make sure that the under drain systems are in good shape. Now, as far as, you know, other innovations, we're doing this work. We're always looking for ways, like, how could we have a more rapid assessment to do this in real time? And so we have done some piloting using drones equipped with thermal cameras, normal cameras, and an acoustic, like a tethered acoustic device that did a complete survey of a few of our spillways, USL and Comanche, and we're assessing to see how well that works in predicting locations where there are problems, and whether this could be used to supplement our normal ongoing inspections. Results look promising, and we see, you know, here on the top right, results of those studies and lining up with actual cracks that we've seen in the field. So this holds promise, and we're always looking for new methods, different types of, rapid survey methods to be able to do proper assessments. So with that, I'll go on. And there's one more. So an important part of dam safety, or really, the safety of all facilities is emergency response and preparedness. And East Bay MUD has a multi-hazard emergency operations plan, which includes emergency plans for dams. And East Bay MUD has worked on this now for several decades and really evaluated different types of emergency scenarios and what might happen to our water system, and plans for our response. And specifically with respect to dams, dams are like an annex under this larger emergency operations plan. And, they're shown here on the right, and they provide guidance on detecting and verifying the situation, notifying local emergency management agencies, and then with them, in coordination with them, responding. Our dams are safe in the very unlikely event of a dam emergency. Assessments would be made, and local emergency management agencies would call for evacuations. And so we want to make sure they know about our dams, they know about our, emergency processes, and we do have exercises regularly to develop those relationships to make sure we can respond in an emergency. And in addition, so we do hold, as I mentioned, annual notification drills and seminars with local dam owners and emergency response agencies in the Pardee and Comanche area. And we are also doing that outreach locally with local EMAs. So on the next slide, now an important part of emergency planning is developing these inundation maps. And again, all of the dams are safe, but it's prudent to plan. And so for emergency planning, East Bay MUD performs hydraulic modeling to determine the flooding that could occur in the highly unlikely event of a dam failure. And it's a very unlikely event because it assumes the dam just disappears. And if all of that water went downstream, what areas would be impacted? And our Water and Natural Resources group has an expert flood modeling group that uses modern methods and actual topography and building profiles in the area to make these estimates. And the whole purpose of these are so that emergency management agencies would know what areas could potentially be impacted. Now, we've had these for decades, and they've been publicly available. It became more important from a regulatory standpoint after the Orville incident. And so now the Department of Water Resources Division of Safety of Dams has these inundation maps online. So if you're interested, you can go view those. We also have them available on our dam safety page at ebmud.com. And so with that, part of this is the importance is, relaying messages on dam safety and incidents related to this or any emergency to the public. And it's a critical part also of our emergency planning and what our communications and outreach plan is. And maybe with that, I'll hand it back over to you, Sun Kwong, to maybe make a few remarks about communications with the public.
Yes, Elizabeth. So public affairs is a key partner in dam safety communication. And we have expanded tools to communicate with external partners, the public, and also other agencies. So these tools include Facebook, Nextdoor, Instagram, X. Our East Bay MUD website is a main way for us to communicate and tell people about information. And also we will issue press release if things is happening. So East Bay MUD also have a wide range of information on its YouTube channel, on our YouTube channel. And part of it is the Water Wednesday. Part of it is a lot of different video to explain our programs, what the things that we do, and some more educational information for people to know more about either dam safety, water safety, and other knowledge. So feel free to check out our website, and you will find out a lot of information on it. So I think with that said, sorry, it's question time. So I will stop sharing and start to ask some of the questions that people have posed. Okay, so let me start at the top. So this is a kind of a statewide question. So as we are a drought-prone area, why not build more dams as an insurance against water shortage? What are the barriers against building more dams? NIMBY or funds?
Okay, I have an answer to that. Dams are a great, reliable water source. They are expensive to develop, but there is dam development going on in the state. Several years ago, the state legislature approved Proposition 1 to provide funding for water resource projects. One notable project that's being funded by that is the Sites Reservoir project in Northern California. That's going to be an off-stream reservoir. That's what I mentioned earlier, that it's going to be a dam that in a valley, but not with a full water supply there. Water will be pumped in from rivers during high water years and stored there, and then available for use during dry years. East Bay MUD is looking at a multi-agency partnership to increase Los Vaqueros Reservoir, and there are various dam water supply projects going on in the state.
Mm-hmm. So when you say regular monitoring, what does that mean? Monthly, annually?
Okay, so we are East Bay MUD's trained staff are doing monthly inspections, formal inspections, as I mentioned, visual and of instrumentation every month. We have at many of our facilities water operators and rangers that are on the site more frequently, weekly, if not daily. So again, are looking for issues that might be occurring. Some of our instrumentation data is real time, so we have that. Annually, there are formal inspections with our regulators, so the Division of Safety of Dams, and FERC Pardee and Comanche, also with FERC, Federal Energy Regulatory Commission, and they go out with us and look at our facilities as well. In addition, annually, we provide lengthy written reports to our regulators about the details of our monitoring, instrumentation, observations all year. If we have any anomalies that we've observed, we've completed an engineering analysis on that, and it's documented there.
So the next question is more about the big picture. So the question is whether or not dams are actually a good way to manage water, or just the best one that is available at this moment?
So that's an interesting question. I think dams are one strategy for water supply. And in addition to dams, of course, there's agencies that have well water, other things like, East Bay MUD is looking at groundwater recharge to provide storage of water and then use of that water. There's river water sources, recycled water that definitely in southern states and the southern part of the state and other parts of the world are looking at a high treatment process with reverse osmosis to actually have a one water and direct potable water reuse. That's years away, but that also is a strategy. So I think East Bay MUD does have a water supply improvements division, and they're always looking at water supply issues, strategies to make East Bay MUD more resilient against drought.
So some of the reservoir and the dams are no longer in use, such as Daingy and Blair. Are these reservoir dams still being inspected?
So We do have several dams that are out of service, and so we are still monitoring those. A few, like San Pablo Clearwell, for example, was a dam and has been replaced. As dams are replaced, or we are certain they're going to be decommissioned, they're breached so that they no longer hold water, so no longer function as a dam or present a hazard.
Mm-hmm. So adding to the technology question earlier, so does East Bay Mud have a sensor or any kind that would give a early alert or warning when the dam is being compromised? So people inspecting a dam may take a little bit time to do that.
So we do have, for example, monitors of flow and spillway flow, so we can certainly see if water, we know what the water level is at any moment, and that's on our SCADA system, which is an electronic system where sensors in the field provide readings to our main office in Oakland, and our operators monitor those. And so they're able to see what's going on, not only with our dams, but our entire system. And we have alarms set for that. We have alarms for our under drains. And when flows are too high, we are immediately alerted and dispatch an engineer to look at that and investigate. We also have been working with the California Geological Survey to install seismographs on our dams and have gathered some data from those from low magnitude events, and are looking at ways to do additional modeling on that to give us a better indication of probable damage. So this is an area that we're, of constant improvement, and East Bay Mud is taking steps to continually improve our ability to monitor and respond.
So the next question is talking about the flip side of the dam. So dam clearly provide many benefits for us human, but it also have some environmental costs. So for example, alteration in fresh water flow, timing of these flows, timing of these flows, the water temperature, and also the impact to fish and other wildlife that depends on the river. So any comments on that?
Yeah. East Bay Mud's Natural Resources Department actively monitors and develops fisheries. We're very proud. This year, I think, was the largest salmon return that we've had, and larger than other river watersheds. So they're constantly doing things to improve habitat and fisheries conditions. At Comanche Dam, at the base there, we have a fish hatchery that's operated by the state, and that provides a significant amount of fish for the environment. East Bay Mud also times and controls releases and has some ability for temperature control, and is currently doing a study for other possible improvements to temperature control. A lot of our reservoirs have towers, as I showed, with gates at various levels, so there is the ability to release colder temperature water, for example.
So do any East Bay Mud facilities, dams or otherwise, produce power, and either hydraulic or solar? And is that power used only by East Bay Mud facilities, or we feed it back into the grid?
Great. Yes, both Pardee and Comanche have hydropower generation, and that is fed into the grid, and we with the California state operator on that, and we have trained hydropower plant operators that run that program. We do have solar. East Bay Mud is has developed over the years several photovoltaic projects where viable, you might see them on our facilities. And we are also, again, looking for that where it's economically viable. Also very interesting, our wastewater plant. As part of the wastewater process, solids are generated, and those further decompose in our digesters, and methane gas is formed. And we have a power generation station that generates enough power to run the plant, and I believe more.
Yes. So where's the dam for San Pablo Clearwell located?
So that's at our San Pablo water treatment plant. So this is a much smaller dam that impounded treated water from the water treatment plant before it goes into the distribution system, and that's been replaced with tanks.
Yeah, and just a note that we will have a open house for the San Pablo Clearwell. So look up the information in our website and come to visit it if you want to. So the next question is, I know dam removal is occurring in some places. Can you address this?
Yes, there have been dam removal projects within the state. Dams ideally are designed for the long term. And, sometimes we are fortunate in our watershed that we don't have issues with excessive sediment formation, but often a lot of sediment gets filled into a dam, making it no longer viable, or there's changes in, sort of water supply profiles. And so that has occurred within the state, not in East Bay mud dams, and we don't envision that at this time.
Mm-hmm. So what is the lowest record water level in East Bay mud dams? And does the low water level affect the dam in a negative way?
So interesting. We have some great photos of the drought that occurred in 76, 77, and really truly low water levels at Pardee Reservoir, where we were close to running out of water, and you see it almost empty and just barely water around the outlet tower. The dam, it can be wet, it can be dry, you have fluctuating water levels. So I think it's just part of, our ongoing inspection. The water is low. It's a chance to kind of take a look at things, but they're designed to deal with changing water levels.
Mm-hmm. So this question is asking, does dams have a shelf life?
That's a great question. So when I went to school, which is now almost 4 decades ago, engineers thought of things as like the useful life of facilities. And you would say like, all right, pipes are supposed to last, 50 years, or buildings, 50 years, something else, 20 years. And dams were thought of as having 100-year life. So that what that meant to engineers is you really had to design them because they were going to be around for 100 years. Well, 100 years has passed for a lot of dams. And so we have a different answer to that. And it goes into like the dam safety approach. East Bay Mud and dam owners are regularly looking at their dams. And for example, we've completed several upgrades at our dams, and we're looking at not just the dam embankments, but the impertinences, meaning the pipes and all of the valves and things. And we've done those replacements. And so the idea is it's like a classic car that you might keep investing in so that it goes on indefinitely.
Mm-hmm. So the question is asked, what feed the Briones Reservoir? And he is just very interested in our topic and want to ask a lot of questions. So
Great. Well, interesting, because Briones Reservoir, I guess technically is somewhat of an off-stream reservoir. It does get runoff from the local area, but East Bay Mud uses Briones water to store water so that it's in a more optimal location for our treatment and distribution needs. So from some parts of the year, water is pumped from our aqueduct system up into Briones and then released there to the treatment plant when it's needed.
so the question is about how has the water quality decreased with the increased demand?
Oh, interesting. I guess what's East Bay Mud is extremely fortunate to have a high quality water supply. And as you can see behind Sun Quang, all of the beautiful water in Pardee there. And the water quality concerns, not so much from increased demands, but due to climate change, we are seeing increased potential impact to water quality. When there's large storms, and we're expecting with climate change larger intense storms, you would have more runoff, potentially more erosion, particularly after fires, and so water could be of a worse quality. East Bay Mud is looking at ways to adapt to that, and strategies for mitigation. So it's more maybe climate related than specifically demand related.
Right, so we have one more question coming in. How is our water supply treated since it is a combination of Maconomy River water runoff and other water source?
Yeah, so East Bay Mud has several treatment plants. Again, fortunate to have a great water supply, and so it would be okay. And we have these on what we call inline plants that do filtration and disinfection. However, when water has more sediments, it needs a full treatment process, including flocculation, sedimentation, and then filtration and chlorine disinfection. And so depending on the water conditions, water is treated at different plants, ramping up the ones that are needed to meet supply and treat more challenging water. East Bay Mud is always looking at this, and we have as a whole series of treatment plant upgrades. We are planning a pre-treatment project in Walnut Creek in order to develop it so that it can treat water with more sediment.
I think one last question before we close it, so people who have more questions can email us. So do the role of Comanche and Pardee Reservoir differ? And if so, how?
So Pardee and Comanche are both reservoirs. Pardee is the primary water source. Comanche is also used for hydropower generation, some aspect of flood control.
Okay, so as I said, if people have more questions, feel free to email us. Elizabeth and her team will be very happy to answer the questions. And one of the things that we mentioned in our presentation is that the dams and the reservoirs actually provide very good recreation for people. So I want to share with you that our next Water Wednesday, which is on June 26th, at the same time, will be H2O Fun. And then it's talk about the recreation opportunities in the Maconomy watershed. So as you can see, that it's like there's a lot of activities that we can do. And then so when you have a chance to go there, you can also see the dams that we constantly monitor and keep safe. So tonight, this will conclude our presentation tonight. Thank you, Elizabeth, for sharing all her expertise on dams, and also our own Catherine Horns. She is in the background to help us answer questions and to make sure everything runs okay. And again, thank you very much for joining Water Wednesday tonight, and have a wonderful evening. Goodbye.